Welcome to Let's Mathematically Prove That Our Stories Have No Bugs. My name's John.
My name's Tim.
And we're from Hobart. Oh, sorry, that's Wellington. Hobart. And we are from a little studio called Yarn Spinner. So we work on Yarn Spinner, dialogue tool used in a lot of stuff. This talk is based on our work that we do internally and for client projects. We originally built Yarn Spinner for a game called Night in the Woods. It's been expanded since then, and now it's being used in a lot of games. A lot of really, really cool games by us and by others. So this is not so much like a mission statement for Yarn Spinner, it's just a thing that we think is true. Computers should do more to make the boring parts of game dev just a lot more bearable for the people involved in building them. So this is not a talk about Yarn Spinner. We will be using Yarn Spinner as the lens to explore the things that we're talking about. This approach that we'll be showing here works for any dialogue system and any system that you use for managing your dialogue. So if you do want to learn more about Yarn Spinner itself, our colleague Paris has a talk later today about that, so go and see that at 3 p.m. Cool, all right.
So the goal realistically is that I think it's fairly safe to say we want to build games with lots of interesting and complex narrative. That's sort of our goal as narrative people. Implicit in this are realistically two different questions. And how can we be sure that every line is reachable? That's sort of the first implicit question in designing our narrative. And the second is, how can we be sure that every quest is completable? Now, not always in one run. You don't necessarily want the player to be able to see and experience everything in one run through, but you do want to make sure that there is a way to do it somehow. And hopefully that's pretty obvious, these two implicit questions, because unreachable content still has to be made. It costs time and money, and that is wasted if people can't get to it. And it also has to be debugged and tested, because you generally don't know if something's unreachable until players don't reach it and your analytics is saying no one's hitting this thing. And this also costs time and money as well.
So the question then we're looking at here is, how do we answer these two questions? Can everything be seen, and can everything be completed in a game? Now, we know how to answer these questions already. The answer is you test the game, and then you test it some more, and then you keep testing until you run out of time and you have to ship. So to give you an example of that, first of all, I'm going to show you a tiny little demo game that we'll be using as the lens for this, and also you can that QR code takes you to the place I'll be demoing from, so you can play through it yourself if you like. Also, if you're watching from home or watching later on YouTube, then you can do it yourself. So. Yeah, cool. All right, cool. All right, so here's a nice, small, simple little text adventure game in which we can play through and do all kinds of stuff. Go to locations, talk to characters, standard RPG stuff.
All right.
So what I will do though, first of all, is just reduce the amount of text that we have on the screen. So there we go. Great. Just to save us a bit of time, because you don't want to read all that.
So we're going to quickly go through the golden path here. So first of all, I'm going to make John, who's our tester, you're going to go talk to the mayor.
Okay, cool. So we're going to go through here and we'll go and talk to the mayor. Yep, cool.
Right, and that will let us learn about the evil prince. Defeating the evil prince is the main objective of the game. Once you've done that, we're going to have to work out how to defeat the evil prince. We're going to do that by going to go find the heir to the family, and we're going to return the heir to the family.
Great, cool. Yep, right, done.
And once you've done that, you're now going to go to the noble's house, and the noble will tell you how to defeat the evil prince.
Great, cool. So we talk to the noble. Yeah, okay, done.
Cool. Hurry up, faster.
Yeah, okay, all right, yeah.
Cool. So the next step is we're going to need some different gear to defeat the evil prince. First of all, we're going to need an ancient knife, which we're going to go get from the witch. So we're
great,
going to go
cool.
to the witch.
So we go to the forest. We go in here. We go into the forest. We go here. We go here. We go
kill her.
Kill the witch. Great, cool.
Yep, sweet. Now we got the knife. All right. Cool. So the next step is we need some armor. So we're going to have to go to the blacksmith, because before we can actually get the armor, we'll need him to make the armor. But before we can make the armor, we're going to need the blueprints. The blueprints are in the sorcerer's tower. But first, we have to ask the blueprint about it. So now we can actually go to the sorcerer's tower. Once we've done that, scholar's tower.
Yep.
And now we can find that. So now we've got that. We can now we could go back to the blacksmith. That's not worth it. We're just going to go straight to the miner because we're running out of time.
Yep.
The miner is going to be able to give us either some curse gold from mithril. We're going to use some mithril because that's more useful, I think.
Yep. Go to town square. Yep.
Now, once we've got that, we can go back to the blacksmith. The blacksmith can make us our armor. Whoops. Now we have the two items we need. The tester made a mistake.
I know. I took the wrong button.
Yeah.
And then I did again. Great. Cool. Yep. Yep.
Okay, cool.
Yep.
Right, now we're finally ready. We can go to the castle. We can biffo the evil prince and win the game. Hey!
Okay. So that took fucking ages, but it wasn't too bad. Yeah. All right. There was a lot of going through the entire thing, and in case you missed any part of what we just did, here's all the steps that I just did. So we do all these various things. We defeat the evil prince.
Congratulations, we did it. And that's one run through.
Yeah, this is only one possible path through the game. So the question then becomes, okay, how many times do we need to play through the game to get it?
So, I mean, this feels like a reasonable question, how many times you have to play it. So let's start something small. Let's say we're only going to make the players take 10 steps through the game. How many paths is that, John?
It's actually 31,800.
Oh, okay, that's okay.
Unique ways to play through the game.
What if we do 11 steps through the game?
Well, that's not much more. That's actually on 94,000.
All right, well, it took 14 steps to defeat the prince. Let's say the player faffs around a little bit, so let's say 20 steps.
Well, unfortunately, I'm sorry to tell you, that's actually 1.7 billion.
Right.
Yeah, not really reasonable. Now, we don't actually test our games 1.7 billion times before we ship, although maybe we should. But if we tried to, then the universe would die before we were done.
So I think it's time to add another implicit goal into our implicit question into our goal here, which is how do we create these worlds without melting the QA stuff into some sort of goo that we use to lubricate the game machine? Yeah, that makes sense.
Yeah.
So I guess the thing is, if doing it manually is no good, what can we do? So the alternate solution, and this is pretty popular, is we're just going to simplify everything. We're going to cut it up into little pieces. Because if we reduce the complexity, we do by definition reduce the amount of testing we need to do. If each piece is independent, we no longer need to test how they interact. We can just make sure each chunk by itself works. This does have a side effect. And this really impacts the stories we want to tell. This is completely unavoidable. If you've designed everything to be independent, they obviously can't interweave with each other. So it limits the stories you can tell. And it creates a world that feels disconnected if they get too big. And I really feel you can sometimes feel this in games where you feel they've gone like, it'd be really cool if we could just have a few more quests. And they've gone, yeah, we can, but they're going to have to start being siloed. And you can sort of feel this in games, sort of the less interconnected, the less twisted they become. It also actually has another issue which is a little bit more insidious, and that is you've actually just moved the complexity from testing to writing time. So it's actually just pushed the load from QA onto narrative. And this raises an interesting question. Is this actually better? And if you make me pick, I would go, I think it probably is, if you make me pick, because it's slightly easier to manage. But it does raise another issue. What if you do want to change something that will impact a previously tested action? Well, the problem is you've now just introduced a regression bug. It never really went away. Complexity is back. In fact, it can't be hidden away no matter what you do. We just changed how it was expressed.
So, well, if we can't test everything and we also can't just shift everything real small, they have a great time over there.
I don't know what they're doing.
The question now becomes, well, what can we do? And so we have an alternate solution, that is make the computer do it. But it's still not reasonable to make the computer try and test 1.7 billion paths. That's still too many paths. So we make the computer do it smart. We do it, there's a variety of different solutions you can apply. And a scale of sophistication that can be brought to bear here, ranging from testing everything manually, which is what we did before. We could identify and test specific paths. Most games do this. Implement stochastic methods, or you could do the really big brain play, and that is solve for every possible universe at the same time. So the key realization that we made when we were designing this system is that you can represent every single dialogue tree like a collection of logical equations. And then that collection of equations becomes a system of constraints, and a system of constraints can be solved mathematically. And the way we solve them is using a tool called a solver. So, what is a solver? Well, a solver is a piece of software that can tell you if a series of constraints are valid or not, and if they are valid, how they are valid. It can give you an example. Or if they're not valid, that is, there's no way for those constraints to work together, it can give you proof that they can't be made valid together.
So it's worth just having a quick diversion. How do these things work? Because like what we've said is very like highbrow, like I can do it.
Maths.
So we're actually going to walk through what a solver will do to validate a series of constraints. This is based on the Davis, Putnam, Lodgman, Loveland algorithm published in 1961, so cutting edge stuff. So let's take this Boolean expression as our constraint that we want to run through our solver. So circle or square and triangle. And I'm actually just going to add one more constraint because otherwise this will finish really, really quickly. So I'm going to also add not circle. So what we need to do is we need to try and find a universe where we've got some true or false values for circle, triangle, square that gives us a valid thing. So what we're going to do is we're going to start just walking down the world of possible spaces. So the first thing is, let's just start with circle arbitrarily, and let's just see what happens if it's true. Well, the first thing is that actually the first constraint, we can have circle be true there. That will actually evaluate fine. But things get a little bit weird when we want to add in not circle. So the question then becomes, well, not circle can't be true because not true is false, so that's not allowed. But can it be false? Well, no, it can't, because we already said circle is true. So that means there's no universe in which circle can be true. Circle will have to be false. So this means we're going to have to keep exploring this world further. So next I'm just going to pick square arbitrarily here, and I'm going to follow the same pattern. What if we start with true? So in that case, is this allowed? So true and something, currently that's okay. So we're going to finally test with triangle. So we'll start with true. True and true, that's true. That will make the whole statement valid. So that means we've actually found a world where this is allowed, where circle is false, square is true, triangle is true. Now at this point the solver would stop because there's no point in going further. We've found an answer. There is a valid way to do this. But just for completeness sake, this is the whole tree. There is no other universe where that's allowed. Now, the final step is to then bring that back into your world of storytelling, because it was sort of abstract by definition here. We're even using arbitrary shapes. But they represent facts in your game. So like circle is the dragon is dead or not. And that big condition is the dragon is dead, or you slew the witch and befriended the dragon. So you can sort of like build up these longer theorems to represent more complex statements that we can assert the truth about our game of. Now this is very brute force, what I just did there. It took like 9 steps or something to determine the variable's value. Modern solvers are a lot smarter than this because you can make some very clever assumptions to cut out huge areas of the search space. But sort of failing any other approach, this is what all solvers will fall back on. If none of the smarts work, you'll suddenly just start brute forcing the whole universe until you find one.
Usually you don't have to, though. So a question that often comes up whenever we talk about this is this AI? And the answer that we have is no, not really, because this came out of an area of research that is in the domain of artificial intelligence research, but isn't really what we today, these days, in 2024, call AI, right? Which means LLMs, large language models. Solvers are old, proven technologies. The basis of them was proven in 1971 by Cook. They were then actually in use in practice for another 20 years before they were proven to be valid for all software problems. And also, a useless computer science history fact, the Boolean satisfiability theorem that we're looking at here was in fact the first NP-complete proven theorem. So you can use that at parties.
Yeah, people love being told that.
Yeah. So they've actually picked up in use quite recently because computers simply just got better. Up until around the early 2000s, computers just didn't really have enough RAM to make them viable for large practical tasks. But these days, they are everywhere. They're in use behind the scenes all over the place and have been for decades. Every modern compiler is using a solver as part of its work. So you might be asking, though, well, yeah, sure, but I could just chuck this into ChatGPT, right? And get a similar answer. So let's compare solvers and large language models. A solver cannot lie to you. A solver does not need to be spoken to like it's an idiot. A solver can explain its results. A solver can exhaustively explore a domain. However, a solver cannot write a bad poem about onions, so points to ChatGPT there, I guess. But more seriously, we actually went, okay, let's actually try and give it the fairest chance we can get. Let's take the kinds of questions that we're asking of a solver and putting it into a large language model. So I use the most powerful model that I currently have access to, which is Gemini Pro 1.5 via Notebook LM. And I basically constructed the natural language version of the question that I'm trying to ask here. Is it possible to reach the end of the game? And what sequence of actions is required? And we, as input, as part of the prompt, we also gave it the entire source code of the game, the exact same stuff that you just saw earlier. And so the first answer was partially correct but incomplete. It says that you need the magic armor and ignores the fact that you also need the magic sword. So I kind of gave a bit of a hint and said, well, what about the ancient blade? Is that important? And it said, no. So it gave a wrong answer in that case. I, continuing this one, like, okay, are there maybe other ways you could reach the end of the game? And it said, well, you could convince the villain to be good. Now,
Easy, right?
Yeah, and so it just made shit up. There's no diplomacy in this game, only violence. So this is representative of the kinds of problems you're going to face if you simply try to shoehorn language modeling, which is a very, very interesting and valuable technique, into actual concrete practical problem solving. It's not a good idea. So,
how would you actually start using a solver in a narrative situation? So the very first step is you need to convert your story into a form the computer can understand. So let's say this is your entire story here. This is a really simple bit of yarn spinner code. You've got two options. You're going to kill or seduce the dragon, as all games do.
Classic RPG.
This essentially means we have two paths through the story. Path one is kill, path two is seduce. This can all actually be worked out automatically by the computer. These paths are very easy to generate. They're called dialogue trees for a reason. Their shape is kind of inherent.
Well, I don't know that many branches come together again in most trees.
That's true.
That's true.
And this actually creates 4 different worlds in which we may want to consider things. So you've got the world where the story begins and ends, 2 different worlds there, and 2 different worlds within those of where you kill or seduce the dragon. And those actually have automatically determined constraints. They're very easy to work out because of the conditions in the branches. Then what you actually need to do is, this bit can't be done automatically, you need to do this one manually. You need to set up the constraints for what you want to test. So let's say you want to test the last line of dialogue, which in this case is this big boring sentence which says, I've either seduced or killed the dragon, but not both. And in which case you could be like, the player can both kill and seduce the dragon, and that's not allowed. So we're specifically saying don't allow that to happen. This could be another one. Or you could just be like, under what circumstances can I kill the dragon? In which case you go, well, I need to be at the end of the game, and I need killed dragon to be true, but I honestly don't care about seduced. And then finally, once you've worked out these constraints, you give them to the solver and go, hey, is this possible? And arguably more important, how is this possible or not possible? Because it's very uncommon you're going to be making a game where there's heaps and heaps of situations where you've just made impossible ends. That's very uncommon. But it's very, very useful for you to be able to test your assumptions around these and go, well, hang on, have I made a mistake that's sort of a little bit more hidden than what it looks like? And that's where they're very useful.
So to try and address this and also to demonstrate how we can make use of solvers in narrative stuff, we've been working on a tool called Story Solver, which is our take on using a solver in narrative. So first of all, I'm going to, whoop, has that done? Yeah, cool, nice. All right, so this is that game that you saw a moment ago. And this is the quest graph shown inside Story Solver. I'm going to make this nice and big. Whoop, there we go. This is the quest graph that defines all of the various quests that are inside that game. So, for example, on the right-hand side here, we have our critical path, where you have to learn about and then defeat the evil prince, but also other quests as well. So Tim mentioned like finding the missing noble's heir, defeating the witch, crafting magic armor, and that's all present there. So this is how we can how we construct the constraints of all the things present inside the game. These here are called quest nodes, and these represent points inside the story. So we start here, and then we move on to a point here, and then we move on to an ending here. These connections between them represent the conditions required to go from one point to the next. And so these define, for example, when to go from the start of the game to we know we have to deal with the dragon, but we have not yet dealt with it, is represented by the player has learned about the dragon, which is in fact this variable here, knows about dragon. And we can test this live on stage here, so attempting all the demo gods. I can say in test mode, I know about the dragon, so I'll set that to on, and so that updates the journal. Very good, very nice. And then I can say, well, the dragon is dead. And now we've also updated our thing. But because we are working inside of a solver, we can actually just assert a truth value about like the overall state, and it will solve everything for us. So if I just clear all our constraints and then simply tell it, I want to be in a situation where the dragon is dead, then it will fill in the fact that, okay, well, that's only possible if you know about the dragon and the dragon is dead. Now, I can also do the same thing for the end of the game. I can say, for example, all right, I want to be at the end of the game here, the evil prince is defeated. So I'll go, the evil prince is defeated, and that actually goes, okay, well, that's only possible if you've completed other quests as well. So it has filled in everything for us. It has said, okay, all of these variables, or rather some of these variables, are now in a true state. The journal now contains updated information, and that's all really good. I can then click download this game state button, and it will take the final concrete values of all of these variables here, save them into a save game file, and then put them on my disk ready for my game to be used. I'll also just quickly copy it to the clipboard, and then if I go here, I can now paste that generated save game that we just produced And so here we go. Our journal is exactly what we expect it to be. And I can walk up to the mayor, and the mayor will say, thank you for defeating the evil prince. I pressed the wrong button there by clicking restart. Cool. Oh well. Load game, paste, talk to mayor. Easy. There we go. One thing also that we have found that this is really, really useful for is this can detect bugs inside your game even before the game has been written. So there happens to be a bug in this game that we found by mistake using this tool, and we thought it was cool, so we left it in because it demos really well. In that, you'll notice that the dragon here has two endings. You can kill the dragon or you can befriend the dragon. The Missing Noble's Heir quest has two endings as well, turn the heir in and help the heir elope. So we have currently told it that the dragon is dead. What happens if we tell it that the ending that we chose for Missing Noble's Heir is in fact help the heir elope? StorySolver realizes there's actually no universe, there's no possible solution for this. You can't be at the end of the game and have those two quests be in these two different states. This is a bug because of a logical error that I made while writing the game, and it caught that at this early stage without me having to even playtest the game, which we think is extremely interesting and cool.
So we can essentially detect soft locks at design time instead of implementation time.
Exactly. Additionally, because this is simply just a graph of all the various things and not the game itself, it's important that we're able to playtest the game automatically and find situations where we've potentially made mistakes. Because it's all well and good to say, yes, these points exist in the graph, but can the player actually reach these things? And so we've written a small tool as well here that allows us to simply, if I hit this button here, it will, there we go. Now it's playing through every single possible path in every single possible part of the game, checking to see if any of those enter a condition where we have made available part of the game. So for example, defeat evil Prince Frederick becomes available when we're in the Dragon Cave or when we're talking to the noble. And it can also detect errors and bugs inside of our code here as well. In fact, if I go into here, and I'm just going to make, let's pretend that I have forgotten to set the flag that we know about the evil prince. I'm just going to comment that out and save it. Now, the game will continue working. That's actually that's actually no problem at all. It still plays, but now the game is broken. There's no way to finish the game. So I can also validate that by running the script one more time, and after a moment it will do some grinding, do some checking, and then try and tell us whether or not it's possible to reach the end of the game. I'm going to fill for time. There we go, cool. And
it's worth saying this actually grows linearly, not exponentially, so it will get slower the bigger it gets, but it won't get exponentially slower.
Yeah, and so I'm going to stop this process here because I know the answer to the rest of these questions, but it's very, very cool to see that this tool, using the solver, is able to detect ahead of time that there's bugs in the actual game as written. Cool, all right.
Back to the slides.
Back to the slides. Cool. So there are some strengths and caveats to be aware of when using a technique like this. I was reminded of a famous quote by the computer scientist Donald Knuth, beware of bugs in the above code, I've only proved it correct, not tried it. This tests only specific interactions and not that the code itself does what you promised it would do. We can find situations that we can detect that a path exists, but not necessarily that the path can be taken. So this doesn't remove the need to test completely. But it does allow you to help to target your testing resources. And it can tell you the paths necessary to see all content, for example, or the steps necessary to reach specific pieces of content. And each path it produces and the constraints form the basis of a new test. In other words, it's test case generation. And you can use these to minimize the amount of overlap between your different tests so that you're not wasting expensive and rare developer time.
So it also can't know about non-narrative changes to the game state. It's highly, highly, highly likely your game players will be able to interact with elements in the game that impact the narrative in a way that you're not really responsible for. Even the best tested narrative game won't stop the player doing something stupid if they try really hard. So there's things that are not your responsibility that suddenly have now become your responsibility. And you're able to test these interactions ahead of time. So it can tell you the world you promised to exist. So it can't know the player did something wrong, but you can use this to go, okay, no, I need to make sure that to get into Act 3, the player will need to have a magic sword. And it can tell you, yeah, that's possible. In fact, it's required. Which sort of leads into the next point. What this is really, really good for is assumption validation. You already know what game you're building. At least I hope you know what game you're building. Otherwise, what are you doing? You already know how it's meant to work. But what you can now do is you can test this assumption. You can test your mental model is what you're building in the game. And you can actually catch these edge cases, trapdoor them, and handle them before you actually have to deal with them at playtime. So spoilers for Baldur's Gate 3, 3, 2, 1, yep, cool. So at the end of the game, there's a really important quest item called the Orphic Hammer, which you need to finish the game. It's not optional. But there's nothing stopping the player just throwing it off a cliff. So if that happens, the literal devil shows up and goes like, you idiot, you dropped it. By the way, I own your soul now. And I really like this because it means someone on the team either discovered it during testing and went, and then wrote a specific handle for it, or ahead of time they went, oh shit, what if the player throws away the damn hammer? All right, and then wrote the handle for it. And I'd love to know which of those two it was. So essentially, you can also use this to find narratively unsatisfying but valid ends. So in the case of the Orphic Hammer, you had no choice. You need to have this handle. But you can also find situations which won't break the game, but which players will be like, well, that's a bit unsatisfying. So if, for example, your game is called I, the player, never simultaneously have 50 gold and a sword, but the story doesn't stop you having 50 gold and a sword, it won't break the game, but the player might be like, oh, that's a bit unsatisfying. I was never expecting to have 50 gold and a sword. So it's not a bug as such, but it is a narrative inconsistency there.
An example of this actually is games in which the player character can romance precisely one NPC at a time, but because of a bug, which we know exists in several RPGs, the game can be in a state where these two people are being romanced at the same time, but they don't have lines about it. They aren't aware of that, and so it just becomes weird. Yeah.
So essentially, this lets you verify the paths you expect are the ones that actually exist. And this is actually something we found during development of our demo game. John was running the path validator, and he's like, wait, hang on, what's that path there? And he jumped into the yarn, and he's like, oh shit, I accidentally set that variable there. Like, we even in our own demo game, we were finding situations where we ourselves had made mistakes in our assumptions.
So the most important and powerful thing that we think is very, very useful is the fact that we can synthesize brand new save game using nothing more than I want to be at a certain point in the game. And it'll give you a complete valid save game that is consistent with how the player got there. We can also ask StorySolver how it found a certain answer. If you say, I want to be at a certain point in the game, we can simply say, okay, cool, you have to have this variable, and not this variable. And so once we have that, we generate a save game, and it's extremely useful. We can also work in reverse. We can take a save and then explore the implications of that state. If you get given a save game from your tester or from a player, you can load that into the solver and then ask it, is it possible given this state to reach the end of the game? And it can say yes or no, which gives you just incredible flexibility and powerful. So this helps you prune or even grow the menagerie of save games that I think every single QA person has a library of for every title, where you just basically collect all the save games and then just use that as a way to jump straight to the end of the game. This can just produce that for us. An example of this happening in the real world, a journalist friend of ours was reviewing a very, very well-known narrative game. It crashed halfway through. It happens, that's fine. Asked the team, can you please send me a save game? I'd love to continue. I don't want to have to, I write a review in which I say, and then I crashed, or I'm unable to complete my review. Neither of those two outcomes are good for anybody. So overnight, he was sent a new save game. It turned out what happened was the community manager of the game stayed up all night playing the game and matching all of the actions he described, just so that he'd be able to continue playing. It all worked out, but that was 6 hours of developer time.
So this sort of falls into what we're kind of calling assisted narrative building, which is simpler to you can't really fuck it up at development time, or you got to try harder. And the idea is it's sort of similar to a lot of programming principles. We've got analysis tools, we've got sort of linters. They're ways that can check ahead of time if what you're doing is going to work the way you think it is. It's really easy to add small inconsistencies when building this stuff. Having something go, hang on. What are you doing? That's not going to work. Before the narrative team is finished is going to save so much time later on. This really enables you to find bugs and quirks way earlier. And as said, we encountered it multiple times just writing this little 5-quest game.
I made a typo and the game said the game's not completable now. I was like, oh, okay, and I fixed it and it's fine. Yeah. So if you think this looks cool, then come talk to us or go to this address and learn more. We're here for the remainder of the conference. Thank you very much. As a reminder, Paris Talk is later on. Thanks for coming.
Same QR code.
Oh, yeah.